Hello everyone. Welcome to this tutorial on analysis of compounds in GChemPaint. In this tutorial, we will learn about molecular contextual menu, save the molecule in .mol format, add and edit a reaction, add reaction conditions and reagents on the reaction arrow, convert reaction molecules into 3D. For this tutorial, I am using Ubuntu Linux OS version 12.04, GChemPaint version 0.12.10. You will also require internet connectivity. To follow this tutorial, you should be familiar with GChemPaint. If not, for relevant tutorials, please visit our website. I have opened a new GChemPaint window. Click on Use or Manage Templates tool. Templates tool property page opens below. Click on Amino Acids on Templates drop-down button. Select alanine from the list. Structure of alanine is loaded onto the Templates property page. Click on the structure and click on Display Area to load it. I will explain about contextual menu of alanine molecule. Right-click on the molecule. A submenu opens. Select molecule. A contextual menu opens alongside. Contextual menu contains different menu items of which I will discuss about. NIST webbook page for this molecule. PubChem page for this molecule. Open in calculator. Click on NIST web page for this molecule. Alanine's NIST web page opens. Web page shows all the details about alanine. Come back to GChemPaint editor. Right click on alanine to open the PubChem page for this molecule. Click on alanine structure on this web page. A new web page with 2D structure and 3D conformer tabs is seen. Click on 3D conformer tab to view alanine in 3 dimensions. Click on the displayed 3D structure. This opens the structure in a separate window with some controls on the top and on the left. Click on the rotation icon to rotate the structure in various directions. On the same page, click on H icon to show hydrogens. These are hydrogens. Let us switch to GChemPaint window again. Right click on alanine. Choose the option Open in Calculator. Chemical Calculator window opens. If not, please install the same using Synaptic Package Manager as in the overview tutorial. This window has 2 tabs at the bottom: Composition and Isotopic Pattern. Composition tab has the following components: Formula, Raw formula, Molecular weight in gram-mole inverse, Compounds elemental mass percentage analysis. Click on the Isotopic Pattern tab. It shows the graph of mass spectrum with a peak at molecular weight of the compound. As an assignment, select other amino acids from the templates list. Obtain their composition and isotopic pattern. I have opened a new GChemPaint window. Let us draw 1,3-butadiene structure. Click on Add a Chain tool. Click and drag the chain to 4 carbons. Click on Add a Bond tool and click on first and third bond positions to form double bonds. Right click at each position to show atoms. Click on Atom and then click on Display Symbol. To convert 1,3-butadiene 2D structure to 3D structure, click on Save icon on the toolbar. Save As dialog box opens. In the File Type field, select MDL mole file format. Type the file name as 1,3-butadiene. Select Desktop to save the file on desktop. Then click on Save button. Alternatively, you can also save the file with extension .mol or .mdl directly. For example, type the file name as 1,3-butadiene.mol or .mdl. Click on Save button. To view the structure in 3D, right-click on the molecule, select the option Open with Molecules Viewer. This is 1,3-butadiene in 3D. Please note, we cannot make the changes in the structure. To rotate the structure, place the cursor on the structure, hold and drag the mouse. As an assignment, convert benzene structure from 2D to 3D. Now, let us learn to draw chemical reactions and reaction conditions. This is a chemical reaction of ethyl chloride with alcoholic potassium hydroxide and aqueous potassium hydroxide to yield ethene and ethanol respectively. I have opened a new GChempaint window. Let us first draw structure of ethyl chloride. Click on Add a Chain tool. Click on the display area. Right click on the chain to display atoms on first and second bond positions. Click on Current Element drop down arrow button. Select Cl from the table. Click on Add or Modify an Atom tool. Click on the third bond position. Structure of ethyl chloride is drawn. Click on Add or Modify a Group of Atoms tool. Click on the display area. Type alc.koh. Click again and type aq.koh. Click on Add an Arrow for an irreversible reaction tool. You can change the arrow length using the scroller here. I will increase the arrow length to 280. Click on the display area beside ethyl chloride. Click below ethyl chloride. Hold the mouse and rotate the arrow to point downwards. Click on the Selection tool. Position alcoholic potassium hydroxide above the first arrow. Position aqueous potassium hydroxide close to second arrow. Select alcoholic potassium hydroxide. Right click on the arrow. A submenu opens. Select arrow and click on Attach Selection to Arrow. A dialog box with heading Arrow Associated opens. Click on Role drop down list. Select Catalyst from the list. Click on Close. Drag arrow to check if alcoholic potassium hydroxide attaches to the arrow as a catalyst. Let us repeat the process for aqueous potassium hydroxide. Drag to see the attachment as a catalyst. Click on Selection tool to select ethyl chloride structure. Press Ctrl C to copy and Ctrl V twice to paste the structures. Place the structures at proper positions by dragging. In the reactions, ethyl chloride reacts with alcoholic potassium hydroxide to give ethene. Ethyl chloride reacts with aqueous potassium hydroxide to give ethanol. To obtain ethene, click on Eraser tool and delete Cl bond of ethyl chloride. Ethane is formed. In the toolbox, ensure that current element is carbon. Click on Add a Bond tool and click on the bond to obtain a double bond. Ethene is formed. To obtain ethanol, press O on the keyboard. Click on Add or Modify an Atom tool and then click on Cl of ethyl chloride. Let us now convert the reactants and products from 2D to 3D. Open a new file, copy ethyl chloride and paste it into a new file. Click on Save button. Save as dialog box opens. Type the file name as ethylchloride.mol. Click on Desktop to save the file on your desktop. Click on Save button. Likewise, copy ethene into a new file, save as ethene.mol. Copy ethanol into a new file, save as ethanol.mol. I had already saved the files on my desktop. I will minimize the current window. And I will go to desktop folder where I had saved my files. To view the compound in 3D, right click on the file, Choose the option Open with Molecules Viewer. Likewise, I will open all the files with Molecules Viewer. Observe the compounds in 3D. Let us summarize what we have learnt. In this tutorial, we have learnt NIST webbook page for this molecule, PubChem page for this molecule, find molecular weight of the compound using chemical calculator, obtain graph of mass spectrum of a molecule, save the molecule in .mol format, add reaction conditions and reagents on the reaction arrow, add and edit a reaction, convert reaction molecules into 3D structures. As an assignment, draw a chemical reaction of propene and bromine molecule with carbon tetrachloride as a catalyst, benzene and chlorine molecule with anhydrous aluminum chloride as a catalyst. Your completed assignment should look like this. Watch the video available at this URL. It summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials, gives certificates to those who pass an online test. For more details, please write to contact@spoken-tutorial.org. Spoken Tutorial project is a part of the Talk to a Teacher project. It is supported by the National Mission on Education through ICT, MHRD, Government of India. More information on this mission is available at this link. This is Madhuri Ganpati from IIT Bombay signing off. Thank you for joining.